Today we will practice solving compound inequalities that contain single-step inequalities. So let's get started. With compound inequalities, we have two or more separate inequalities, and they are joined together by either the word and or by the word or. So in this case, these two inequalities are joined by the word and. So in this case, we're looking for the intersection, where they overlap or where they intersect, and what they have in common. When we solve compound inequalities, we're going to solve each of these compound inequalities separately and then combine the answers using either and or. So for this first inequality, we have 2x less than 10. To solve for x, we're going to divide both sides by 2. And we end up with x less than 5. For this second inequality, we have x plus 5 greater than negative 5. So we'll subtract 5 from both sides. We end up with x greater than negative 10. So now let's graph x less than 5 and x greater than negative 10. So we have x less than 5, so we'll have an open circle at 5, and this will shade everything smaller than 5. We also have x greater than negative 10, so we're going to have an open circle at negative 10, and this will shade everything bigger than negative 10. So the overlap will be all these numbers between negative 10 and 5. And then when we write this in interval notation, we start with the leftmost point. In this case, that's going to be negative 10. So we have negative 10 on the left, and it is not included, so we'll use an open parenthesis. And then a comma. And then the rightmost boundary, that's 5. And then a parenthesis to show that 5 is not included. So this is the solution in interval notation. We have all numbers between negative 10 and 5, excluding or not including negative 10 nor 5. So the boundaries are not included. So when we see an answer that looks like this, we do need to know what context this answer is in. I just solved this problem, and I know I wrote things in interval notation. So I know that negative 10 comma 5 within a set of parentheses is an interval notation. Now in other parts of the class, this would be an ordered pair. You would need to know either by being told directly or by the context that it's used, whether this is interval notation or an ordered pair. Then let's try another one. This one is joined by the or keyword. So this is going to include everything that's in either of those two sets. So we'll solve the first inequality first. We have 3y less than negative 15. So to get that y by itself, we're going to divide by 3. We have to do that with both sides. So we have y less than negative 5 for the first inequality. Then we have y divided by 7 greater than or equal to 2. So we're going to multiply both sides by 7. We end up with y greater than or equal to 14. So graphing this, we have y less than negative 5. So on this number line, negative 5 is going to fall between two grid marks. So we're going to put an open circle here. And I'm going to go ahead and label this as negative 5. And this is all values less than negative 5. And then we have y greater than or equal to 14. So that would be a closed circle at 14. It'll be all numbers greater than 14. Now, since this is R, it can be in either of these. So I'm going to go ahead and shade both of these. So we have all numbers bigger than 14 and all numbers smaller than -5. Now, I didn't do this on the previous graph, but I'm going to go ahead and delete these arrows here to clean up the final product. And then writing this in interval notation. Again, we'll start on the left, and this goes all the way to -infinity. So our left interval will be -infinity, and with infinity, we always use a parentheses. And then a comma, and that ends at -5. Once again, -5 is not included, so we'll use a parentheses. Since R is a union, we're going to use this symbol here to indicate these two intervals are joined with union. And then the left boundary on this one is 14. 14 is included, so we're going to use that square bracket. And then comma, and then this will go to +infinity, and once again with a parentheses. And then finally, we have -3 less than z/2, which is less than or equal to 2. So this is two inequalities that are combined, and they're joined via an AND statement when you see it written this way. So let's first separate this into the two inequalities. We're going to take that center portion, that z divided by 2, between the two inequality symbols, and then we're going to take what's to the left. So this is one inequality. So we have -3 less than z/2. And then we would solve this inequality by multiplying both sides by 2. We have -6 less than z. And then we'll rewrite this as z greater than -6. And then the second inequality, once again, we'll start with what's in the middle, that's z/2. And then we're going to take what's to the right. So we have z/2 less than or equal to 2. And then we'll solve this by multiplying both sides by 2 to get that z by itself. We end up with z less than or equal to 4. When written like this, these are connected or joined via an AND. So graphing this, we have z greater than -6. We'll have an open circle at -6, and then shade everything greater than -6. And then at 4, we have a closed circle because 4 is included. So we have a closed circle at 4, shade everything less than that. This is an AND statement, so we're looking for the overlap. So that's going to be everything between -6 and 4, not including -6, including 4. Did you notice that we solved both of these inequalities using the same operation? We multiplied by 2 both times. So there is another way of solving this problem. So we have -3 less than z/2 less than or equal to 2. So you do not have to split this up into two inequalities. So to get the z by itself, we need to multiply by 2. And then what you do to the middle, you also have to do to both sides. So we're going to multiply both of these sides by 2 as well. We end up with -6 on the left, and then in the middle we have z, and then less than or equal to 4. So we end up with the same answer. And then in interval notation, we have an open parentheses, and then -6, comma, 4, and then a bracket. All the numbers between -6 and 4. We do not include -6. That's what the parentheses indicates. However, 4 is included, and that's indicated with the bracket. A great way to learn is practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 2 problems. So for this first one, we're going to solve each of these inequalities independently. So we have a minus 2 less than -8. We'll add 2 to both sides, resulting in a less than -6. For the second inequality, we have 1/5 a greater than 1. 1/5 a can also be written as a over 5. So this is a over 5 greater than 1. Solve this by multiplying both sides by 5, ending up with a greater than 5, joined via an or statement. So here's the graph of the solution. And then here is the solution in interval notation. Again, using that symbol for the union of the 2 intervals. So we have the 2 inequalities combined into one statement. When written like that, they are connected via an and. That's how they're joined. You can solve this in 2 ways. You can go ahead and split this into 2 inequalities. So this on the left would be the first inequality. So -2 less than or equal to 9 plus b. And then the second inequality will be on the right here. So you have 9 plus b less than 17. Solving these, we end up with a -11 less than or equal to b, which is b greater than or equal to -11, and b less than 8. Now this can also be solved by keeping this compound inequality together. So we're going to subtract 9 from both the left, the middle, and the right. We end up with -11 less than or equal to b, which is less than 8. So here's our solution and the graph of our solution. And then written in interval notation, we'll use that bracket to indicate that -11 is included. And then the other boundary is 8, and it is not included. So all numbers between -11 and 8, including -11, but not including 8. Continue practicing solving compound inequalities, and I'll see you in the next video.